welcome to the second in our Talking Data AI webinar in the series. Great to have so many of you on the call today. I'm your host, Lyle Ritchie, Head of Talent Solutions here at Head Resourcing. For those of you who don't know, Head Resourcing is a digital IT and change recruitment company. I'm delighted to be joined by Doug Lothian, CTO at Zelim, where Doug will talk to you about the AI journey Zelim are going on. For those of you who don't know, Zelim are a technology solutions business with a mission to make unmanned search and rescue the industry norm. Before I pass over to Doug, just a couple of quick points. Doug will talk for around 30 minutes and there will be a 15-minute Q&A session. So please, if you could thumbs up the questions you want the answers to, and there is a chat box which you can engage with throughout the webinar series. Perfect. So really looking forward to this, and I will hand straight over to Doug. Doug, over to you.
Brilliant. Thank you, Lyle. And thanks for inviting Zelim and myself, obviously, to talk. We've been friends of Head for a long time, and I'm sure Hugh at Head we'd tell you lots of stories going back 20 odd years. So I've known Head for a long time. I'm really pleased with to work with you guys again at Zelim. So what we're going to talk about today. We're going to talk about smart technology for search, rescue, and security. That's really what we're about at Zelim. We help search and rescue, defence, cruise, energy companies achieve faster detection, alerting, and tracking of threats to life and safety of navigation. Now, what does that mean? Effectively, if someone falls, we're there to help find them when they fall in the water, either during the fall element or when they're in the water. Our systems can do that, and that can be from an aerial asset, that can be from a platform, or indeed from a quayside. But equally, the asset itself often needs defended, and you can just look and see what's happening today, especially in Ukraine, with the Ukrainians attacking the Russian fleet, with the Houthis attacking carriers in the Red Sea, etc. Actually, vessels and platforms are now also becoming targets. That's primarily happened in the defence realm. It's now starting to happen in the commercial realm. It may also start to happen, unfortunately, in the future in the kind of leisure realm, and we'll touch on a little bit about that. Our solutions, they exceed US Coast Guard detection standards, and I'll touch a little bit on that. They exceed international man overboard standards as well. And of course, it's a maritime environment. It's quite a chaotic environment, so they have to work day, night, and in poor visibility conditions. As a company, we've partnered with global naval, it's not companies, but global navies, as well as coast guards, as well as different energy organisations, both on the renewable side and indeed the oil and gas. Oil and gas was a dirty word, but I think we're all now acutely aware that it's something that we also need to look after the people and the assets out there just now. So, what are the challenges? Just looking at it, I mean, I've mentioned a little bit the global insecurity. In half year two, 2024, there was about 80 incidents because of missile strikes, drone attacks, or hijackings of commercial vessels. Predominantly, this was actually in the Red Sea with the Houthi rebels. We've also got huge numbers of people crossing oceans, and they're crossing oceans to escape either poverty for economic reasons, or also because of obviously instability in their regions. And they're crossing across the globe. This isn't something we often hear about this in the English Channel, but it's actually happening across the globe where people are crossing waters and unfortunately getting into trouble. Over 200,000 crossing the Mediterranean or the English Channel last year. We've also got a lot of people offshore. So you don't realise how many people actually work offshore. So about nearly 2 million people working offshore on assets. Now, some of those assets are fixed assets, like platforms in the North Sea or the Gulf of Mexico, Gulf of America. I'm not sure which one to call it nowadays. But also, just looking at, they sometimes have incidents. So I would ask the question, how many commercial vessels have incidents each year, but our marketing people have put it in here. About 5% of the global fleet of commercial vessels bang into each other or bang into something each year. So that's about 3,100 vessels have a collision. So every vessel, according to statistics, will have a collision in a 20-year period. 65% of those collisions or collisions are actually attributed to human error. So although they have lots of systems on board, those systems aren't foolproof. And indeed, we had an incident in the North Sea recently, obviously, where a vessel collided with a carrier just off Grimsby. There was also an incident where a platform was actually struck recently by a support vessel going at high speed. And unfortunately, both of those are down to human error. Passengers, there are a lot of people going offshore on holidays. Some of you may have been on cruises yourself. 2023, there's 31 million passengers, and that's growing. The cruise companies, if you look at Royal Caribbean, if you look at Disney, if you look at Norwegian Cruise Line, all of these companies, MSC as well, all of these companies are building larger, more fantastic vessels. Some of these vessels are really floating palaces with lots of entertainment solutions on board. Nearly 40 million passengers are predicted by 2027. Um, the UK MAIB actually estimate there's about 1,000 man overboard incidents each year. That's not of the cruise ships. Let me just underline that. That's not 1,000 of cruise ships. They estimate 1,000 man overboard incidents each year globally. So that's about three a day. People fall overboard into the water from leisure, from commercial, or from cruise. Um, Quick challenge for you guys, and if you can, please answer some of these questions in the in the chat box, and Lyle will try to answer or read them out. Does anyone know what's the maximum survival time in the North Sea? So if you fell in the North Sea in the clothes that you're wearing today, so not in a dry suit, not in a wet suit, but actually whatever you're wearing today, what's your maximum survival time in the North Sea? If you can answer that, we'll go back to it in a second.
Yeah.
Second question. According to the US Coast Guard, if you had a SAR helicopter, a search and rescue helicopter, so one of the big red and white S-92s or AW189s flew over you, what's your probability of being seen if it flies directly over you? And then lastly, how good are we as humans, at spotting and recognizing and tracking things in a chaotic environment? The sea is obviously very chaotic, with movement everywhere, different from waves breaking to flotsam and jetsam to simply the different waves. How good are we at spotting that? We got any answers for that,
Yeah, we do.
Lyle?
Yeah. So just the first question ranges from 30 minutes, 40 minutes. Scott's put 2 hours. Um, so yeah, that's the kind of
Around that
range.
range.
Yeah.
Interestingly, so for that one, a lot of our beliefs are based on what we've heard from the Titanic disaster. And
Okay.
actually, hypothermia can set in relatively quickly, but actually the survival times are quite lengthy. In a 15 degrees Celsius water, which it's approximately 14, 15 degrees Celsius just now, just in some of the shallow areas of the North Sea, you've got about a 17 hour
Wow.
life expectancy survival time in the North Sea. Now that can vary, different people, different fitnesses, different body sizes, etc. can change that, but that's the maximum. So it is quite lengthy. So long as you have a life jacket on, you can survive. However, if you do not have a life jacket on, that's when things start to get difficult. The 30 minutes is a very interesting one. Around 80% of deaths occur in the first 30 minutes, and that tends to be people who are not wearing life jackets. After around 27 minutes or so, the cooling of your muscles actually stops you from swimming, so you end up with
Right.
swim failure.
Okay.
And there's a number of deaths that occur because of cold water shock as well. But your maximum survival time is 17 hours. According to the
Wow.
US
Okay.
Coast Guard,
Yeah.
SAR
So
helicopter.
I've got here 5%. Um, yeah, a couple of 5%,
Yeah.
6%.
It's actually interesting that people think it's so low, and
Yeah.
it is low. It is low. It's around 18%,
Okay.
18%. So it is low,
Right.
but they've got some amazing kit on board. But unfortunately, there's always a human in the loop. There's usually a human, and unfortunately, we as humans, and that comes down to the next question. We as
Yeah.
humans in the loop are not very good at spotting things in a chaotic environment. We're very good at spotting moving things in a static environment. So in a
Right.
wood, we're very good at spotting a deer or spotting a rabbit in a field or something like that. But actually, if lots of things are moving, we're not very good at spotting those things.
Right.
Um,
Okay. Good.
okay, so this is a real life incident. This was actually there's a film and a book came out about it. It's not without hope. It was a number of US college football players went on a fishing trip, and unfortunately, their vessel capsized, overturned. They were in the water, I believe, for it was like 3 or 4 days in total, and unfortunately, a number of them died. Only one person survived. And from his survival story and from the actual accounts of the Coast Guard, we can see that. But actually, on the right-hand side, you can see all of the search patterns that were conducted by the Coast Guard, and you can see many of them are overlapping. Some of those are from vessels, some of those are from aerial assets, so helicopters and fixed wings. Um, and interestingly, they were overflown multiple times, and sometimes multiple times in a 24-hour period. So actually, we're not that great at spotting things in the water, and that's really where we came from a Zoe perspective. So Zelim, we developed a product called Zoe. Um, oh God, no, let me jump back. We developed a product called Zoe, and we designed this product to try to support search and rescue, to try to find that small thing in the water, that really small thing which is a head in the water. Now, finding people in the water isn't something new. Over 80 years ago, the US Coast Guard started a study to look for interesting submarines and vessels. It was during World War II. And that study was looking for large things in the water. And that's became the basis for what's called search theory in the modern search and rescue world. Now, search theory relies on things called lateral range curves. Lateral range curves are those curves on the right-hand side there. It looks like a normal distribution or a bell curve, but actually it's defining on the x-axis the distance laterally, so left and right, that you're able to detect a person in the water and the probability of detecting that person. So you can see laterally here, you've got 0 to 0.1, 0.2, 0.3, 0.4, and then probability up the left-hand side. It's a very narrow window that you can theoretically spot somebody 100% of the time, and then it tails off as the person goes away, or as the person ranges away from the asset. As I mentioned, that's theoretical. In reality, down the bottom, you can see here the probability of being spotted, even if overflown, is only 18%. So there's a difference between theory and real life operational practicality, and that's because we have to consider all of the different variables. So particular target objects have different detectability indexes. They may be different clothing if it's a person. It might be a different life raft. It may be a different size of object, spotted from different distances. And the environment changes, the conditions change. So different sea states, visibility can change. All of those things affect it, and that's why operationally the levels are so low. Um, Interesting stat there. Only 19%, or actually less than 19% of all searches for a person in the water actually yield a saved life. So it's imperative that number one, if you do go out in the water and you play in the water, you have a life jacket. Number two, you obviously have some sort of communication or signaling device. But actually, equally for our search and rescue providers, that they have a solution that allows them to improve their detection capabilities. Um, and as I mentioned, that's why we developed Zoe. Zoe was looking for this small thing in the water. We looked at classical detection solutions and we looked at artificial intelligence. And this was way back in 2021, 2020, 2021, really before artificial intelligence was a buzzword. We started gathering data in the water of people in the water, and we were using different solutions, different types of infrared cameras, as well as different daylight or RGB cameras. Um, we then went on an exercise actually with the UK Coast Guard in 2022, and we started working a little bit closer. The UK Coast Guard and the US Coast Guard happened to be on that exercise. US Coast Guard took interest, and we ended up with a contract with the US Coast Guard in 2023. It's a cooperative research and development agreement, which is really to look at the employment of artificial intelligence to detect detect, recognize, and track objects in the water, and also to find a scientific measure or scientific way to measure detectability. It sounds like a very simple thing to say. How do you measure detectability? But until there are various methods, is probably the easiest way to do it. You can get into a lot of theory talking about this, but detectability is a very difficult thing to measure. Um, so we've developed this solution in conjunction with the US Coast Guard, with our CRADA, but also with the UK DASA or DSTL. So that's the Defence and Science Accelerator and the Defence Science Technology Labs down at Porton Down. So we've worked with both these guys to develop this solution. We have it deployed operational. It's in offshore energy, oil and gas and renewables, cruise, and we are working with our defence partners in various navies as well. How good is Zoe? So I mentioned the 18% probability of detection. Zoe actually offered a 5 times higher, so 96% probability of detection from double the distance. And one of the key things here is actually looking at distance. So we've 5 times higher, double the distance than traditional mechanisms, and we've got a very low false positive rate. False positives, for all you AI people will know, is can be a killer. It's a balance between assuring your true positives and your false positives. The picture on the right hand side is actually a true incident. This was the Hendrika vessel that listed in the North Sea. It listed in about a sea state 8, so that's about a 14-meter wave. Most of the crew were rescued. Unfortunately, it became unsafe to hoist off the last crew member, the captain, and the captain was actually asked to enter the water. He entered the water, and unfortunately, the crew were so busy in the aircraft, flying the aircraft and avoiding various other things, they missed the person entering the water. They were picked up later, sometime later, but it wasn't an immediate detection, tracking, and pickup. We ran Zoe on the same footage that was supplied, and we detected that person in the sea state 8, 40-meter waves within 3 seconds of them entering the water, and we were able to track them. So had Zoe been on board that helicopter, that person wouldn't have had such a long wait, and potentially it could have ended much worse. So lateral range curves, very narrow band for higher detection capability, and the dots down the bottom picture there shows the white dots show the successful probability of detection or successful detections. The black dots show missed detections. So in a search swathe, an area that the asset is searching, they are missing targets, and this is actually taken from the US Coast Guard's own literature. Zoe, on the other hand, through the full extent, the full field of view of the cameras that Zoe is deployed on, we have a 96% probability of detection, which means that we don't miss those objects. So if we are searching for an object or searching for a person in the water, we've got a much higher probability of detection of finding them, which should yield more lives saved. But actually, in all of this, lives saved is the human aspect. There's always accountants, and there may be some accountants on the call. There's always accountants are looking at the numbers. This also means you've got a far more efficient search. It means that instead of having to search an area 5 times to then have a high degree of probability that you have a high degree of coverage, you can search it once and have the same degree of coverage. We worked it out on the incident that I mentioned earlier, the Not Without Hope incident. They could have saved $1.5 million in search asset use if they had Zoe on board and working in that particular search. So quite a saving on a single search basis. It also means that if an asset it doesn't have to search an area 5 times, if the person's not in that area, they can be off searching in another area, which again means that you're using those scarce resources more effectively and efficiently. So that's one aspect of Zoe. So Zoe were originally designed to help find people in the water, a very small thing in a chaotic environment. And really that's where the MOB side started off, looking for a person in the water. We were then asked by a number of customers to say, well, could you actually find a person if they fell off a ship? Could you find it earlier before they hit the water? And that's where our MOB solution comes in. We're able to detect a person as they fall. So that 1 second that they've fallen from, say, a deck before they hit the water, we detect that. And we detect that to the international standard, the ISO 21195 standard. Watchkeeper. This is where if we could find little things in the water, well, actually, we can find bigger things as well. So, uncrewed or autonomous surface vessels are currently causing havoc, obviously, with the Russian fleet. There's no reason why that couldn't be turned against a friendly fleet as well, or against a leisure or commercial assets. Watchkeeper and Shield, these two solutions, offer the capability to find small, low radar cross-section objects before they become a threat to you or you become a threat to them. So Watchkeeper looks forward and makes sure that we don't bang into things and that can be static object or dynamic. And Shield covers the whole vessel to make sure that perhaps some malicious objects don't come and attack you. So looking at them independently, man overboard detection, I've touched a little bit about this, but we use the artificial intelligence to detect both the falling person and obviously alert to that falling person. Now, many solutions simply do frame by frame detection. We can't do that in this environment. We have to look at the behavior of the falling person as well to ensure, first of all, it is a person, and secondly, they're behaving like a falling person would look. We then will alert, but we also have the capability, based upon pan-tilt zoom cameras, to slew that camera onto the location of the person in the water and to track that person using the pan-tilt zoom of the cameras. So again, using the artificial intelligence capability and the tracking capabilities of Zoe, we're able to not only detect the fall in the water, track where the person is in the water, but because we can also then determine the latitude and longitude in the water, we can simply send a rescue boat straight to them, and that saves a lot of time and effort, obviously for the rescuers, but also more frequently will yield a life saved. That system is designed again to 21195 man overboard detection standard, and that requires that we have about 95% detection capability. In our own tests, in an operational environment, we far exceed that, and we are close to 100% detectability throughout the range. It also integrates with the systems on board. There's no point in having a standalone system. This system has to integrate neatly with systems aboard your asset, be it vessel or platform. Moving on, Watchkeeper. Watchkeeper 225, as I mentioned, looks forward for any potential hazard. Um, the term tends to be live wide area moving imagery. And really, what we're looking for is collision avoidance. We're looking for things that we may bang into or things may bang into us. We mentioned that humans are great at spotting things that are moving, especially in a static environment. But they're rubbish at spotting things that are static in a moving environment. So actually, some of the things that get banged into most often are things like navigation marks or anchored ships, as happened in the North Sea of Grimsby. So we're very good at spotting things that move, not so good at spotting things that don't move. So we spot low radar cross-section vessels. Now that could be leisure vessels like ribs, or in the case of obviously the migrants crossing the rubber dinghies that they're crossing in. Also spots dynamic or static hazards. That could be larger vessels or smaller vessels. And the static hazards really are your navigation marks that quite often get damaged on entry and exit of ports. We augment that with AIS data, so we can pick up AIS targets and obviously augment that on screen. But we don't need that. We can actually have non-AIS assets and also track both where they've been and where they're going to give a predicted vector for those. That all integrates with the slew to queue of the pan-tilt zoom cameras and can also integrate with the onboard radar or MARPA systems. So quite a comprehensive solution. That goes forward really into your Shield 360. So looking around the whole perimeter of the vessel, and it's the same idea. It's making sure that vessel is protected, and it gives you the threat vector designation, giving your vector predictions as well as your closest point of approach and time to closest points of approach. We can also designate friend or foe as part of that, and again use the electro-optical or infrared cameras to slew to queue onto it. Now, one of the questions we often get asked is why do we choose artificial intelligence as opposed to choosing a classical detection solution? Um, now, classical object detection, I think a lot of you guys will know this, tends to require a solution like background subtraction. So effectively, you're looking for pixels that change on screen, and you're highlighting those pixels on screen, and that works great in a static environment like a desert environment. So in defence, there's been lots of work put into moving target indicators for on land, where you tend to have trees or buildings or rocks even that are static. And you can then look at which pixels change, and which pixel change then tends to be a target or a moving target. That doesn't work so well in a marine environment because the sea itself is constantly moving. You have white caps and you have reflections of the water. The other thing about classical object detection is it may tell you that something is there, but it doesn't tell you what that something is. Our solution allows you to recognize what that thing is, and that helps us to then designate whether that thing truly is the thing that we're looking to detect, or if it's something else. Also helps you detect whether that thing may be a friend or a foe. So we may have something, for example, falling off a vessel, but is it truly a person? If we alert that's a false positive, that can then annoy the crew. If it annoys the crew, the system's likely to get switched off. A diving bird can look very much like a falling person, both on infrared as well as on your electro-optical cameras. But actually, if we then look at the characteristics of a diving bird and we look at the pattern that the bird makes, we can quickly eliminate that from our from an alert and not bother the crew. Equally, from a vessel perspective or an object on the water, we can determine if the thing is what we think it is. If it's known, it can become a friend. If it's not what we think it is, it can become a foe, and we can continue to monitor it. Um, Throughout this process, we've learned a lot of lessons, and I've tried to just basically put them down into a couple of different classifications here as to what those lessons are. The first one, I would say, and we fell into this back in 2022. We had some fantastic results straight off the bat from our artificial intelligence. A lot of this was lab gathered. We had fantastic scores on our mean average position or F1 scores, and we believed that we had a solution that was ready for the operational environment. I would say from your own perspective, if you're doing this, don't be overly confident with your lab test results. You have to get out into the operational environment, especially if it's a chaotic environment, and test that early, test it often, and gather as much data as you can from that relevant operational environment. Um, for us, that has been the theme all the way through. And those two images that you see on the right-hand side highlight that. We often are out gathering data in the worst conditions you can imagine. Now, that could be throwing, not people, that's actually a dummy getting thrown off a cruise ship. That's a heated dummy getting thrown off a cruise ship at night time with quite a congested background, which just makes everything very complicated for the AI detection solution. The image underneath is actually in the middle of the North Sea, and that's a fog bank. So that is a fog bank, and the item that's been highlighted is a vessel that's approximately 1.5 to 2 kilometers away from the platform. So again, nighttime fog bank operational environment, and we're demonstrating that capability. That's really the things that you have to do. That comes through actually in the items that I have here. So lessons learned on data collection. You need large, relevant, and diverse data sets. They need to be collected in an operational setting, and it has to be under varied environmental conditions. Um, Obviously, we see cars on the road. We now see cars on the road with a lot of the automated features. And over the last 5 to 10 years, the cars have been getting better and better, but they're still collecting data. They're still improving because the operational environment is such a difficult environment to work in. Labeling. For us, labeling is key. We have tried lots of approaches with automated labeling solutions, etc. But actually, human labeling is by far our uh, our um, uh, um, our most successful approach. We need accurate labeling, accurate annotations, and it has to be captured with supporting metadata. All of that supports our training. We, just as an example, we collect and annotate in the region of about 120 to 150 frames per month. It's a big overhead, but it definitely yields benefits. Independent validation sets. There's no point in having a great training set if you can't validate what's out there. So actually, you need a truly independent, relevant and validation test set. We started again having fantastic results, but then we found that we'd actually cross pollinated between our test set and our training set. So we spent a long time collecting truly independent data that could be validated in order to assure the results that we have. And that was required both from a regulatory perspective, but also a customer perspective. Our customers have been very rigorous as you can imagine, in assuring that the AI solutions that we have are correctly tested and correctly validated. And the last thing is your operational acceptance testing. There is no point in just testing during the summer. When you are doing your operational acceptance testing in a relevant environment, you have to do it in the worst conditions. We had tests running during Storm Eowyn last year, last January. So when the winds were blowing at 130 miles an hour in the midst of the North Sea, we had our system up and running in those environments to prove its capability, to validate what we had seen both in the lab and in our tests. So you need extended operational acceptance testing in all operational environments and all operational conditions. Otherwise, what you have is really a fair weather system. Quick picture. This is a quick video. This is Southampton docks. This is on board a vessel. This is an example of our watchkeeper solution, really just looking out for static dynamic objects, etc. Unfortunately, in this video, there's nothing that caused a collision risk. But this just gives an example of the system. It's obviously speeded up. The red funnel ferries don't move that quickly if you've ever been on one. This is the vessel exiting. You see the nav marks being detected there. They're the static objects we want to avoid. We can see a cruise ship here exiting, and the skipper always has to keep an eye on that. So we're highlighting that there is a moving object. Objects that are moored, we tend not to highlight. So because we're taking in the AIS records, we understand objects that are moored or perhaps at anchor, in which case what we tend to do is not highlight those. We only highlight the objects that the engine's running and are defined as being underway, or static objects such as nav marks. You can see here very little. In fact, very little, if any, false positives being alerted here. We really are just highlighting the objects that the skipper needs to see. And that's just a quick example of our watchkeeper solution looking out from the front of a vessel coming at Southampton. If I jump on, the team that we have, very diverse team. We've got teams that have worked in defence, we've got teams that worked in technology, we've got teams that have worked in local government, and we have a fantastic team. None of this would be possible without both the team, the senior team, but then also actually the engineers that we have. We've got a fantastic team of engineers, really enthusiastic and dedicated team of engineers, and that's really what we recruit for. We recruit for the attitude and the enthusiasm, and it's one of the things that I know Lyle has always enjoyed, I think, or hopefully enjoyed trying to find the guys that we have. Now, I think I've just hit the 30-minute mark, bang on just now, so I'll take any questions if anyone has any questions.
Fantastic. Thanks so much for that, Doug. Bringing Zelim to life. Zoe, fascinating. The products you've developed, I think, and how harsh the environments you've had to test these in as well, in this weather. So no, really interesting stuff. There is questions coming through. I'll just kick off firstly, Doug. Going back to Zoe and the start of this process and going through the kind of AI route, I think people will be interested in finding out why did you engage and think about AI then at the start and that sort of kind of journey you've gone on.
Yeah, no problem. So I mentioned the difference between AI and classical detection. Classical detection, I'm just the simplest form is the background subtraction. Many of the team have worked in defence. Many of us have seen the false positives that come up actually when you're looking at some of these solutions using classical detection in operational assets. I'm not going to mention the technology of the companies, but we took part in an exercise recently in Canada. It's called SAREX. It was off Vancouver Island. There were aircraft flying using traditional search and rescue solutions on board. They had a huge number of false positives to the point where the operators were ignoring and simply using their eyes to try to find objects that may be a person in the water. Compare that to Zoe. We took the route because we wanted to not only detect that something was there, but to positively classify that was the thing that we were looking for. And that was really where the AI came in. And then taking it further, we could also then add behavioral aspects to it. So we could add a temporal aspect, understanding what the behaviors the target had exhibited, to then again determine whether that was something that was of interest to us that we should highlight. we during that exercise, we were looking for two missing people in the water from a vessel offshore. We ran that. We detected all of the objects that we're looking for, the two people in the water. We detected the vessel also, and we had zero false positives during that full exercise. So
Okay.
really, that was why we went down the route, and that kind of validates our thinkings. Our
Great
thinkings.
stuff.
That's not a word, but thinking.
Yeah, great stuff. No, good answer. I'll just crack on. We've got lots of questions here. So,
Sure.
um, how scalable is the Zoe system for deployment across fleets, ports, offshore installations?
Yeah, it's a very, very scalable system.
Okay.
So, from our perspective, we can deploy in multiple ways. We can deploy at the edge, so we can have processing carried out actually aboard the asset. So, if you imagine if you have an offshore oil and gas platform or a renewable floating wind platform, or indeed a cruise ship. We can actually be processing aboard and providing real-time alerts to the people on board. We can also process in public cloud, for example. So we can be processing um, uh, um, remotely. So again, using LTE or SATCOM links, we can have a camera, for example, in a port, looking out, looking for objects, and we can then process in the cloud there. And we also have our own private cloud for security that we can also process. So as a system, we would argue that it's almost you can never say infinitely scalable. I know a
Okay.
lot of us do, but it's a very very scalable solution either in the cloud or at the edge. As a system, also, we provide real-time over-the-air updates in the same way as a Tesla car would.
Hmm.
So, as new functionality becomes available, we can offer that functionality to our users again through the LTE or SATCOM secure links, and they can toggle on or toggle off those new features as they like.
Okay. Good stuff. And I think you've answered one of the other questions just regarding do you employ public cloud for processing or storage, or do you process at the edge?
Yeah,
Um,
yeah, we can do
so
both.
you can do
Yeah,
both.
and
Okay.
yeah, and really the beauty there is that we cannot say that we're camera agnostic. I think a lot of times uh, people say that we like to we have a set of cameras that we like to use, but really most cameras today, most electro-optical cameras use very similar sensors. Most IR use very similar sensors, so we believe that we could be agnostic that way. Which means that you can almost take your cameras that you have fitted today, and so long as they can be purposed for the role that we want them to use, we can then process, for example, in the cloud, very, very fast setup and turnaround.
Okay. I think that moves nicely on to Hugh's question just regarding what other use cases can the tech be used for? So canal paths, lakes, rivers, etc.
Yeah. Yeah, 100%. It's really because we've focused on the maritime environment. There are a number of solutions out there that look at the terrestrial environment, and we've focused from inception on the maritime environment. Um, when we're looking at waters offshore, you obviously have a lot of movement there. When you look towards harbours, when you look towards canal paths, when you look towards reservoirs, you tend to have less movement. It actually
Okay.
makes it slightly easier for us to detect the things. So absolutely, any deep water environment, reservoirs, quarries, canal paths, and inland waterways, absolutely fine.
Okay. Sounds good. Thank you for that. Couple more questions here. So how do you merge the data from multiple sources, say visual, infrared, or do you process each separately and combine the results?
Um, to be honest, it depends on the situation. So what I would say is we process each individually and we combine the results. It's probably the easiest. If you
Okay.
try to do one or the other, you're going to end up with some latency. So we try to think of it. The way we discuss it is almost like a hive where you have worker bees. And the worker
Hmm.
bees are obviously gathering the data and can provide a level of processing. And then we have the queen who's managing it, and that's really our nexus layer. We call that the Zoe Connect, which is the layer that combines everything and presents it.
Okay. Good. Makes sense. And just so Alan Wallace has asked, are there any other providers doing this, or are you spearheading this approach using AI? Is it being taken up by companies, cruise shipping companies? So I suppose, yeah, who are your competitors? I know you said about Zoe and the competitive advantage, but is there anyone else doing this type of thing in the market?
There's other people. It's a
Okay.
nice thing from our perspective. It's quite a nice thing that there are competitors because that validates that there is actually a market. So for the man overboard solution for the person falling overboard and detection, so there's an international standard, ISO 21195.
Hmm.
Really, there's two main companies in this field. There's us and there's a company called Mars, and Mars have a solution. Both Mars and ourselves are currently ISO 21195 Stage 2 certified. So both very good products, both in the competitive marketplace, both offering comparable solutions. Um, we are the only of the two at this stage that also offers the in-water detection. So not only detecting the fall element, but also then detecting the person in the water and tracking that person in the water. Um,
Okay.
you take that step further, you look at the watchkeeper. There
Hmm.
are other solutions in the marketplace offering comparables. So Orca AI offer a similar solution for the watchkeeper detecting objects that could cause a collision risk. And Orca AI really have a footing in the commercial shipping environment. Sea.ai are another company, and they predominantly are in the leisure yachting market, but they are now expanding more into the commercial marketplace. You take it a step further and you look at the Shield or the Watchkeeper 360. Um, our solution there, we believe, is actually the only solution that provides the full 360-degree coverage on a vessel. There are other solutions. So the radar solution aboard does provide 360-degree coverage, and we're not trying to replace radar. We augment with the radar. Um, Radar is very good for larger objects, but smaller with objects with low radar cross sections, obviously, it can be very difficult to find. Equally, high precipitation, or if they turn the gain up because of sea state, then even some vessels can become obscured in those situations on radar, and that's the beauty of our solution. The
Okay.
last one, from a defense perspective, is radar is an active solution. So if you're pinging someone with your radar, they know that you are watching you. They know that you've been picked up. Ours is completely passive. So our electro-optical infrared, if it is watching you and tracking you, it is completely passive, and you don't know that we're watching.
Okay. So it seems like you're in a pretty, competitive place, but you're at the forefront with your product, and driving that forward. So that looks good. So just cautious of time. Somebody's asked, obviously we've been talking about Zoe specifically, but what, I suppose quite high level, what other products do you have alongside the kind of AI tech within Zelim?
Yeah, no worries. So we started off, and I think you introduced us as our aim was to make unmanned rescue the norm. Back in 2020, we designed an unmanned rescue vessel. So actually, we built a full scale prototype, uncrewed vessel, and that uncrewed vessel we had authorization to run on the River Forth, and we did for really about two and a half years. We achieved the world's first incapacitated casualty recovery from an uncrewed vessel. And we then worked with oil and gas company North Star Shipping to design a full-scale vessel. So from the prototype, from the 6.5 meter prototype, a 7.5 meter fast rescue craft, incorporating our novel technology for lifting the person from the water. That was launched about 2 years, a year and a half ago was launched. And we're actually building another version of that at this stage, specific for the cruise market. That's a fully uncrewed vessel, and as I say, can lift a person from the water. Now, a component of that is an unmanned rescue conveyor that we call Swift, and that can be retrofitted to other vessels. So this Swift conveyor can be retrofitted, for example, to pilot vessels or rescue vessels, or crew transfer vessels that may be operating and may have a man overboard. It's already been certified as a primary life-saving device. So it's a life-saving apparatus, and it can be the primary life-saving device. And it doesn't require, again, any human to touch it. So if you have a mass casualty event where you're lifting, say, four or more casualties from the water, then a person doesn't have to physically lift. Interestingly, we talked about the US Coast Guard earlier. Aboard a US Coast Guard cutter, it takes four people to lift one person from the water. if they are able, whereas our solution can lift a person without a human touching it. And an interesting anecdote that we're told, unfortunately, we're all getting bigger. We all obviously eat too many cakes, eat too many pies. So we are getting more heavy, and when we're wet, we get even heavier. There was an instance in the US where a person had fallen overboard from his leisure vessel. US Coast Guard cutter came to get him, and unfortunately, he was quite a large chap and was unable to be brought aboard the cutter. They were forced to tie a rope around the person and then tow him to shore to invoke the rescue. Had our solution been there, we would have been able to lift him or multiple people aboard, and obviously that embarrassing event would not have happened
Yeah.
for the person.
Okay. Wow. So yeah, lots going on there then, and thanks for describing some of the other, projects you're working on. I think it would be worth noting if anyone wants to find out more, please visit Zelim's website and on LinkedIn, Zelim's page as well talks a lot about the events that they're on and the products they're developing. More information there. So that's it. Thanks to you all for joining today. Doug, a massive thank you to you for talking to us about Zoe and Zelim and the journey you're on. There's lots of information in there that I'm sure people on the call have taken. So thanks again for that. Just quick one from me. I will be hosting the third episode in our series on the 2nd of July with Gary Crawford from Owendale Advisory Services. He is going to be looking at when intelligent software understands the user on the 2nd of July. So please join me then. There will be a break in the summer and we'll kick this off again on the 27th of August. So please look out on our socials for that. Thanks again. See you all soon,
Brilliant.
guys.
Thanks, everyone. Thank you.